In this video, we're going to be taking a look at graphing on the coordinate plane. Now you need to have your Go Math book out, turn to page 331, get out your math journal and a pencil. Now before we begin looking at graphing on the coordinate plane, we're going to look at the essential question, that is, how do you locate and name points in the coordinate plane? So let's take a look at all the different points in the coordinate plane. So some very key terms that we'll need to take a look at on page 331. We can see a coordinate plane is formed by two number lines that intersect at right angles. The point of intersection is 0 on each number line. So we can see right here 0 where the different number lines intersect. Okay, they form a right angle, so that will be 0. Now the two number lines are called the axis. The horizontal line is called the x-axis. So you can see x-axis, this is the horizontal line, and the vertical line is called the y-axis. Now the point where the two axes intersect is called the origin. So you can see right here, origin is 0. The two axes divided the coordinate plane into 4 quadrants. So you can see this is quadrant 1, 2, 3, and 4. You can see it goes counterclockwise as far as the order. So that's a little bit about the coordinate plane. Now let's take a look at what's called an ordered pair. And I understand this is something that you've learned before, but we'll just review it. An ordered pair is a pair of numbers that gives a location of a point on a coordinate plane. So a point which is right here on our coordinate plane. The first number tells how far to the right, positive, or left, negative, the point is located from the origin. So it always tells you the x-axis first, which way to go, to the right if it's positive, or to the left on that x-axis if it's a negative number. So you always think about x comes before y, so you're moving along the x-axis before you move along the y-axis. Now the second number tells how far up, positive, or down, negative, the point is located from the origin. So we can see if we have an ordered pair, let's say it's 3 and -2, so that means we need to move 3 places on the x-axis to the right because it's positive. -2 means we'll move down 2 spots on the y-axis because it's negative. So the numbers in an ordered pair are called coordinates. So those are two coordinates there, 3 and -2. The first number is the x-coordinate. The second number is the y-coordinate. Okay, so remember, x comes before y, so that's the reason how you can remember which axis you move along first. Now let's take a look at example 1. It says identify the coordinates of each point. Name the quadrant where each point is located. So let's take a look at point A. So we can see point A is located down at the bottom here. Now in order to figure out where point A is, we can see point A is 1 unit to the left of the origin. Okay, so we can see the reason for that is because it's lined up with -1 on the x-axis. So you can see it started out at the origin. You always start out at the origin or 0, move left 1. Okay, so we know it has a coordinate -1, and then it moved down 5. Why is it moved down 5? Because it must have been a -5 as well. Okay, so we can see, and we can see the y-coordinate is -5. So it's written -1, comma, -5, and then which quadrant is it? So we know it's 1, 2, 3. So it's counterclockwise, quadrant 1, quadrant 2, quadrant 3. Okay, so we can see that A, the ordered pair, is written -1, -5, and we know that it's in quadrant 3. The reason why we know it's -1, -5, we can see our point is in line with -1, and it's also in line -1 on the x-axis and -5 on the y-axis. So let's take a look at point B now. So we can see point B, first of all, started out with 2 units to the right on the x-axis. Remember, your first step is always moving either left or right on the x-axis with your ordered pair. So +2, it's in line with +2. And then you can see 3 units up on the y-axis. The reason why we go up because it's a positive number. Okay, so we can see that it would be written as 2, comma 3. Remember, it's always parentheses around your ordered pair. And we know that it's located in quadrant 1 because we have 1, 2, 3, and then 4 as far as the names of the different quadrants. So let's take a look at question 1, do some reflecting on what we know about coordinate planes. It says if both coordinates of a point are negative, which quadrant is the point located? So let's think about this. It can be any negative number. So let's say -1. We'll start on that origin. We'll go -1 on the x-axis, and then also -2 on the y-axis. So anytime both points are negative, the quadrant will be 3. And I want you to write that down. It will always be 3 as long as both points are negative. Now, if only one point is negative, it's not going to be the case. So, but they're asking if both points are negative, it will always end up in quadrant 3. Now let's take a look at describe the coordinates of all points in quadrant 1. So all the points in quadrant 1, we would say that both coordinates are positive if it ends up in quadrant 1. So we can do +4, +5 will be quadrant 1, +1, +2, quadrant 1. You can see both coordinates have to be positive in order for the points to be in quadrant 1. Now let's take a look at number 3. It says explain why point -3, 5 represents a different location than point 3, 5. So we can see that the x-coordinate in point -3, 5 is -3, which will be to the left of the origin. Remember, whenever we start out negative, we go to the left of the origin. The x-coordinate in point 3, 5 is 3, which will be to the right of the origin. So instead of going to the left, which is negative, we go to the right, which is positive. And then from there, both of them do go up, okay, because both 5, that second point is 5, which means you can see it would move up on the y-axis. Now let's take a look at 4 and 5. We'll do these together. So it says identify the coordinates of each point, name the quadrant where each point is located. So let's take a look at G. We need to find what this is. So we can see it starts out, it's in the 4th quadrant, so that means it has to be positive along the x-axis. So we can see it's +4. So we'll write that as the first number in our ordered pair. So +4, and then you can see it moves down on the y-axis. So since it moves down, it's a negative number. We need to figure out what that negative number would be. So we can see it's right in line with -4. So it would be 0.4, -4. Now let's take a look at the quadrant it would be a part of. You can see it's quadrant 1, 2, 3, whoops, and 4. Okay, so we could see it's 0.4, -4. The quadrant it would be a part of would be quadrant 4. So let's take a look at letter E. So we start at our origin, and this time we have to move left on the x-axis. So since we're moving left on the x-axis to find our plotted point, that means it's going to begin with a negative number. So you can see that E is in line with -2, so that would be the first number in our ordered pair, -2. We'll put our comma there. Then we move up on the y, which means it's going to be a positive number then. So we have -2, and we can see that E is right in line with the 4, where we move 4 places up on that y-axis. So it's 2.24. And the quadrant, you can see we have quadrant 1, quadrant 2. You can see E is in quadrant 2. Now I'd like you to take a look at number 5, and I want you to identify the coordinates of each point F and also point H. Write those out in an ordered pair, then also name the quadrant. And you can work on this now. So you can see for 5, the answer is 0.32. It's in quadrant 1 for F. For H, point -1, -3, and you can see it's in quadrant 3. Now let's continue to take a look at graphing points in the coordinate plane. Now we've looked at where both numbers in the ordered pair to have some type of value. Now let's take a look at points that are located on the axis, are not located in any quadrant. Points on the x-axis have a y-coordinate of 0, and points on the y-axis have an x-coordinate of 0. So let's take a look at this. So it says graph and label each point on the coordinate plane. Now we've already looked what we do if we have a negative point and also a positive point, negative on the x-axis, positive on the y for A. Point B is a little bit different. We have 0.3 and then 1.5. So we have 3, which is a positive number, on my x-axis, so we move to the right 3 times. And then since it's 1.5, we plot our point between the 1.5 and the 2 within quadrant 1. Now 0, -3 is a little bit different. So again, we start out at the origin. So now since it's telling us 0, it's the first number, we don't need to move anywhere, but it says -3, so what we do is just go down three places on that y-axis, and you can see C is plotted right there between the 2 and the 4 on that y-axis, representing 0.0, -3. So remember, if there's a 0 for either x or y-axis, that means you don't need to move left or right on the x-axis or up or down on the y-axis. So let's take a look at a few of these problems now. It says graph and label each point on the coordinate plane. So let's take a look at P. We have point -4, 2. So first of all, my first number, my ordered pair represents how many places to the left or right I need to move on the x-axis. So since it's negative, I've moved to the left -4 or 4 times. And then it's +2, so that means I move up on my y-axis, and I can plot my point right there. I'd like you to do this with me as well. And this is point P, so we'll just put a P next to this. Now let's take a look at Q. It says 0.3 and then 2.5 for my ordered pair. So since it's +3, I'm going to move to the right on my x-axis 3 times, and then it's +2.5, so I'm going to plot my point right between the 2 and the 3 on my coordinate plane. I'd like you to do that with me as well. I'm going to label it Q. You can see that's quadrant 1 and then quadrant 2 for point P. Let's take a look at number 8. We have R -4.5, point -4.5, and -5. So we go to the left on the x-axis 4.5 spaces. Then we move down on the y-axis 5 spaces. So we can plot our point just right there and label that R. Let's take a look at S. We have 0.4, -5. So since it's the first number in our ordered pair is positive, we're going to move to the right 4 times. And then we're going to also need to plot our point at -5. So we go to the 4, and we go down -5. I was just making sure everybody was paying attention. So -5, we'll plot our point just like that on our coordinate grid, and we will label it S. Now let's take a look at letter T. A little bit different here. We have point -2.5, 0. So remember, the first number in our ordered pair represents however many places to the left or right we need to move. So we're going to move to the left 2.5 times because it's negative. And then the second number in our ordered pair tells us how far we need to move up or down on the y-axis. It's a 0, so that means we don't need to move anywhere. So I will plot my point right between the -3 I'm sorry, right between the -2 and the -3, and I will label that T, just like that. Now we're going to take a look at reading scales on axes. And it says the scale of an axis is the number of units that each grid line represents. So far, the graphs in this lesson have a scale of 1 unit, but graphs frequently use other units depending on the types of numbers that are in the problem. So let's take a look at understanding the different scales. In example 3, it says the graph shows a location of a city. It also shows the location of Gary's and Jen's houses. The scale on each axis represent miles. So it says use the scale to describe Gary's location relative to the city. And it's important to understand that each square is 5 miles on a side. Okay, so we can see, the reason why we know that, we have 0, and then we can see there's a line there. Just go the other side, line there, and then 10, so we can see each section represents 5. So it says Gary's house is at -25, 15. So we can see -25. Why do we know it's -25? Because it's in line on my x-axis with -25. Why do we know it's 15? Because you can go up or positive on the y-axis. And you can see it's right in line with the 15. So, which is 25 miles west on my coordinate grid, and then 15 miles north of the city. Now let's take a look at where Jen's house is in relation to Gary's house. And the way you can figure this out is knowing that each square represents 5 miles. And we know that Jen is a total of 6 square units away from Gary. So since within our coordinate grid we see that Jen is 6 units away from Gary, we would not say that Jen is 6 units away from Gary. We need to understand and realize that each grid square is 5 miles on a side. So you just take 6 total squares times 5 miles per square. It's going to equal a total of 30 miles away from Gary's house. So we can see how coordinate grids are used to represent real-world situations. And let's take a look at number 11. It says Ted lives 20 miles south and 20 miles west of the city represented on the graph in example 3. His brother Ned lives 50 miles north of Ted's house. Give the coordinates of each brother's house. So we can see 20 miles south, which would mean the distance you would travel on the x-axis. Okay, so we could see, since that's south, would be -20. And then 20 miles west, you could see that would be another -20 to the west. And you can see, you can just plot the point right there where Ted lives. We could see Ted lives right there. So -20 since it's south, and also -20 since it's west as well. So point -20, -20. Now his brother Ned lives 50 miles north of Ted's house. So what we will do with that, we'll see where you would plot that point on this coordinate grid. Now we understand we got to start at Ted's house. We don't start at the origin, we start at Ted's house. So since we're starting at Ted's house, it's just saying 50 miles north. It's going to start in line, be right in line with -20 on the x-axis. So that'll be the first part of our coordinate grid, I'm sorry, of our ordered pair. And then we need to go 50 miles north, which is 10 grid boxes, which would be right in line with 30 on the y-axis. So we would have -20, 30 would be the point of Ned's house. Now remember, they weren't saying it's 50 miles north of the origin or anything like that. It started with Ted, so just 50 miles north. We already know that Ted is -20 on the x-axis, or 20 miles west within the coordinate grid, and Ned just lived 50 miles north of Ted. Now I want you to take a look at number 1. And I want you to fill all those spaces in. And you can work on that now. So you can see for number 1, we have left, up, point -5, 1. It's in quadrant 3. So we're going to wrap up this video on graphing on the coordinate plane, and I suggest you take a look at page 331 and be very familiar with those different terms. If you have any questions about this concept, please come and see me.